Chapter 9, Section 2, Plate Tectonics and Seafloor Spreading. Earth's major roles. According to the plate tectonics theory, the uppermost mantle along with the overlying crust behaves as a strong, rigid layer. This layer is known as the lithosphere and is broken into plates that move over the asthenosphere, which is the molten upper portion of the mantle. Oceanic and continental plates come together, spread apart, and interact at all the boundaries all over the planet. Think about an eggshell that's been broken as it floats over the surface of the egg itself. A plate is one of the numerous rigid sections of the lithosphere that move as a unit over the material of the asthenosphere. Earth's mid-ocean ridge system forms the longest features on Earth's surface. The system winds more than 7,000 kilometers through all of the major ocean basins like the seam on a baseball. Seafloor spreading. We know that the seafloor is spreading because we use technology called sonar, which stands for sound navigation and ranging. It's a system that uses sound waves to calculate the distance to an object. As scientists mapped the ocean floor using sonar, they found long curved valleys along the edges of some ocean basins, and they call them deep ocean trenches. The mid-ocean ridge is this long chain of mountains extending the length of the ocean. A rift valley is a deep central valley that runs down the center of the ridge. If we look at this picture right here, we can see that seam in that gray color. And if we follow it all the way around, we can track it, and it follows the entire globe. We're not used to looking at maps that look like this, these relief maps. We're used to looking at the continents, but not the ocean floor. When we look at the ocean floor, if we essentially drain the oceans, this is what we would be looking at. You can see that rift valley. So as those plates are pulling apart, they're creating a seam that's opening up. If we could go down to the bottom of the ocean, for example here, this Atlantic Ocean, this ridge, this is kind of what we would be looking at. In the process of seafloor spreading, new ocean floor forms along Earth's mid-ocean ridges. It then begins moving slowly outwards across the ocean basins and finally sinks back into the mantle beneath deep ocean trenches. In the process of subduction, the ocean floor is returning to the mantle as it sinks beneath a deep ocean trench. So in this way, our seafloor, we know, is the youngest of the Earth's crust. It's continually regenerating. Evidence for this seafloor spreading includes magnetic stripes in the ocean floor rock. We can see earthquake patterns that lead us to believe that the seafloor is spreading, and we can also measure the ages of ocean floor rocks. Here we see this diagram from your textbook. We can see in the mid-ocean ridge, the warm magma is pushing up. It's causing some warping. It creates this rift valley as it pushes those plates apart. It fills in with the sea, and then we eventually have this oceanic ridge that forms. So here's our oceanic crust. So this is being formed here, and then it's being pushed outward towards the continental crust. The continental crust is much older and harder, and so when it meets it, that young, soft crust will actually go through a process we call subduction. It subducts underneath that crust, and it creates these mountain ranges. Paleomagnetism is the study of changes in Earth's magnetic field, as shown by patterns of magnetism in rocks that have formed over time. We know that over time, the Earth's poles have shifted. So at one point, the North Pole was the South Pole was the North Pole, and then they shift back. We describe that using normal polarity, which is when rocks show the same magnetism as the present magnetism field. Reverse polarity is when rocks show the opposite magnetism. The discovery of strips of alternating polarity, which lie as mirror images across the ocean ridges, is among the strongest evidence of seafloor spreading. Here we can see normal magnetism, the rock polarity, and then it reverses. And then it reverses again, so we're back to the normal. So we can see these stripes on the ocean floor with polarity. We can also see them in lava flows, so as the lava flows out of these fissures in the sides of volcanoes, or they come out the top of the volcano.